I'm a senior product manager for NGINX. I've been at NGINX for about 6 years. Before that, I was a site reliability engineer, so my background's in operations. But today I'm going to be talking to you about polyglot design patterns, specifically around NGINX Unit, which is a tool that we have that's open source. So the agenda today is, first I'm going to tell you a little bit about NGINX if you don't know what NGINX is. By the way, raise your hand if you know what NGINX is. Awesome, so cool. Everyone knows NGINX, been around for a while. I'm going to talk a little bit about the polyglot approach and kind of some of the caveats to that, of why maybe your organization might want to adopt the polyglot and maybe reasons why you might not. And then I'm going to talk about specifically how NGINX Unit helps actually help your organization adopt a polyglot type of architecture. And then I'm going to give some examples of how you can actually deploy a Python application with NGINX Unit. So if you guys know NGINX, you may have known the story of how NGINX came to be. It got started by a man named Igor Sisuev here. He originally designed NGINX as an open source tool to be used to sit in front of web applications that couldn't handle more than 10,000 concurrent connections. So at the time, Apache would basically fall over if it received more than those amount of connections. So he created NGINX OSS, which is the open source web server, reverse proxy, load balancer, content cache. It's slowly grown over the years into kind of a multifaceted, I like to call it the Swiss Army knife of the web. And it's gained immense popularity in the community to be served as that tool, as a static web server. That also goes to say that we also, he started managing the product, and it get to a point where he really couldn't manage it on his own time and work his full-time job. So he decided to start a company. And so he started NGINX Incorporated here in San Francisco back in around 2014, 2015. And over the period of time that I've worked here, this is just kind of a snapshot of all of the features and functionality that have been poured into the open source version of NGINX. Things like HTTP2 support, stream support, being able to do TCP and UDP type proxying and load balancing, multi-datagram support, thread pooling, all these cool enhancements from a Linux perspective as well. And then also they've built up NGINX Plus, which is the commercial version of that. But I'm not here to talk to you about NGINX Plus. I'm here to talk to you guys about NGINX Unit, and more specifically about why it's considered a polyglot application server, and how you guys might be able to use this tool in your own ecosystem. So why actually have a polyglot approach? Well, I think most organizations in this day and age adopt a polyglot approach, whether they like it or not. And this comes from inherent knowledge of different languages that have been inherited from different engineering groups. Different people have different reasons why they have actually adopted these different languages. For some people, it's because they've worked in a position where they've been in an operations type job where they've had to manage different languages. Like for me, I came from an SRE role where I had to know a little bit about everything, somewhat of a generalist. But over the years, engineers grow and they start to kind of be more aimed at a certain language. And this goes without saying that there's all sorts of different, and I would probably venture to say at the companies you guys work for, there's different types of languages being used in different parts of the business, right? NGINX specifically, we love Python. We use Python for a lot of the tooling that we use in our infrastructure. We use it for some of our products that are SaaS-based products, NGINX Controller. We also use Python for a lot of the long-based threading stuff that we have to do with our customer intake and stuff like that. So we love it, Python, and we know you guys, obviously, over the years, you have reasons why you've adopted Python. You can see here that, according to the TOB index, it's the most popular programming language. It's very simple, easy to learn. I think I don't have to tell you guys that Python is a very awesome language, right? But other languages have their caveats. A lot of these languages are older languages, and they have inherent reasons why they've been adopted over the years. Java is an older language, easy to learn. It's been widely adopted over the years. It's probably one of the more popular languages. Also JavaScript, PHP, Go. You get the idea. There's different reasons why organizations are adopting different languages. But having multiple languages, I think, can be actually extremely valuable. It gives you access to a larger pool of developers to hire. So if you're in a situation where you're trying to grow a business and you have certain developers that are specializing in a certain language, that's going to inhibit you if you strict to one language, right? A lot of times it will also help organizations get unstuck out of their ways if they're stuck in one particular language that they choose. And it will help them develop with more agility in the long run, right? And they can also find ways to do interesting things that maybe they are not able to do with existing languages. But it also comes at a cost, right? If you start to take on more languages, that means that you have more frameworks, right? And a lot of these frameworks can be non-customizable. So you can sometimes be restrained at the life cycle of that framework. You can also have encapsulation where like certain teams have like tribal knowledge of the code, but they don't understand how the framework is actually working under the hood. They're building around the framework and they're building features and functionality on top of that, and they don't actually day-to-day interact with the source code for that framework. And there also is a chance that data or that code can also be unsecure in certain ways too, because it is somewhat out of view and it is somewhat out of maintenance. And then you also run into the issue where there's a possible variation between different frameworks, right? So if someone's running Python Flask and they're building a web application, and then you have another team that's building in Go and they're using the HTTP implementation of the Go language, you might see different variations in the behavior between those web applications as well. So there's all these kind of like caveats to adopting frameworks, and I'm going to talk a little bit about how you might try to abstract some of that stuff and actually build raw code in a polyglot approach. And you also run into the fact that if you have more tooling, or I should say if you have more languages that you support, of course you're going to have more tooling, right? You're going to we already have a rich ecosystem of different tooling that's being used, right? We have the client-side tools, which are managed, that are used by the user, whatever browser they're using. You have the edge-based stuff, which is stuff that's usually managed by like an operations team or a DevOps team, things like NGINX, Cloudflare, F5. You have this kind of like abstracted layer in this that maybe like if you're a developer or if you're a DevOps, maybe you manage that, but at a very minimum. And then you have all these other tools that you start to gather along the way. So you might use NGINX to serve your application in PHP FPM, but you might also use HAProxy to serve another application that's written in some other language or Apache. And then on top of that, you also have the application servers or the process managers or the runtime interfaces that you have to deal with on different languages as well. So again, it gets more complex with the polyglot approach. You start you have to have a Node.js server for Node. You have to have a PHP FPM server, et cetera, et cetera. And then on top of that, that's where the application code sits, right? So what is NGINX Unit? So I talked a little bit about NGINX open source at the beginning, and that I always like to make the contrast that NGINX open source is kind of its own thing. It's been around for a very long time. It was created in 2007. NGINX Unit is a new tool that has been developed by the same creator, Igor Sisoev, to build on top of that. And his hope is actually that it will be the future of NGINX and actually eventually replace NGINX for a couple reasons. NGINX has been kind of used as a static web server, being able to deploy in front of your application. It's got file-based configuration, so you have an actual NGINX configuration file. You have a process manager that can manage the NGINX process, and you can use a binary tool to execute that stuff. It supports HTTP, but it also supports other protocols like WebSockets, HTTP2, soon HTTP3, gRPC. It also can do TCP and UDP-based proxying and load balancing. So it's kind of lived its life as a reverse proxy in a web server. Well, Igor created NGINX Unit as a layer into the application space. So it is built on the same core functionality. It does have reverse proxy functionality, and it does have load balancing functionality, but it's strictly right now a tool to be used to deliver an application over HTTP, and also, I don't have listed here, but also TLS. So it can actually handle TLS connections as well. But on top of that, he's added a lot of features that allow you to configure first of all, API is the first-based approach to configuration. So if you want to configure NGINX Unit, there is no config file. It is a JSON structure. So you issue a command either by HTTP call to update that configuration, or you can do that over the Linux file system as well. And it is, like I said before, it's API first-based configuration, and it allows you to build applications in all of these languages in a polyglot approach. So Python, Perl, Ruby, Node.js, Go, Java as well, and PHP. Whereas NGINX open source is really the only application gateway tool we have is PHP. We can actually run like PHP FPM and run PHP code through there. So it's really trying to go more towards this new approach that applications are driving innovation and compacting all of that tooling into one binary. So in a nutshell, NGINX Unit basically runs your application code, and it simplifies and redefines what an application stack would look like. So if we look back at this diagram that we showed before, where we have different abstraction layers, we can see that the typical web application, if you're running multiple versions or multiple kinds of applications, you're going to have a subset of tools. We know that it's going to be complex if you're supporting more than one language in an organization, right? So what NGINX Unit does is it compartmentalizes all of those tooling that you would normally have to use for running your applications, running your frameworks, running all that into a compact binary, NGINX Unit. And then your application code is sitting in a completely different space, and you're able to build your application behind that, right? So it has a full-blown HTTP implementation and a full-blown TLS implementation, so you don't have to worry about HTTP level, programming that into your application. You don't have to worry about anything. You can just write the application, and you can let NGINX Unit handle all of the connection handling, and it can also serve static files as well. So if you need to serve like HTML, JavaScript, stuff like that, and that's all in a single configuration and network runtime. And again, being an API, and I'm going to get into how the API works, you can just issue one API call to configure one or multiple applications sitting behind NGINX Unit. So if we look down in the nitty-gritty of how Unit works, clients are communicating over the network, right, using HTTP to Unit. Unit has a router service that allows you to essentially route traffic to different versions of the application, or by doing static file serving. So if you want to build your application and you want to have some HTML or some JavaScript or CSS, you can serve that through Unit, and then you can have separate application runtime processes that can handle different data or different types of operations. And these are completely isolated on the Linux subsystem. So in other words, if the Go binary was running, it has no access to the Python application and the internals of what's going on in the code. It's completely isolated from a security perspective. So if we go an abstraction above that and we think, okay, we have the client HTTP connection where the router process is handling URL-based routing, so it can also do, in other words, like /login could be a PHP application, authenticate could be a Go language. So it has URL-based control and manipulation that you can do, so that it will automatically route to the version. So you could actually have a Docker container running with NGINX Unit with all of those languages running as separate binaries, and NGINX will handle that with one configuration and one API call that you have to make. It is a JSON REST API, and it happens in real time, and it handles gracefully as well. So if you make a change to one particular application, all the other applications will not be affected. They'll continue to operate. And as you make that API call, any existing connections that are handling the existing application will be continued to be served. And then once those all trail off and new connections come through, they'll hit the new version of the application. So this allows you to do seamless upgrades without having to worry about any kind of downtime to the actual user. And really, a lot of people say like, oh, well, why another application server? Well, the real goal of NGINX Unit was not only to give this ability for different languages or different programmers to be able to build applications around NGINX Unit, but also to standardize on the actual communication that's happening. So from a HTTP perspective, it's fair to say that NGINX specifically is pretty good at HTTP, right? We've been doing it for a while. So the implementation that we have put into NGINX and NGINX Unit are completely according to RFC, so completely up to spec. It also aims to have these existing, older languages that can actually be modernized with a real-time configuration with that JSON REST API. So it gives it an ability so that the actual developer or the person who's actually delivering that application to production can actually just manage a single REST API to make those changes. And then on top of that, it can be end-to-end TLS. So you can issue an API call to update the TLS information with the same API. So you can upload a certificate and create a TLS endpoint over that API as well. So if we look even deeper at how that kind of works, we can see that there's what's called a listener. So NGINX Unit has a listener that's listening over TCP or TLS, and it's accepting connections over that, obviously over networking space, right? It has the ability to pass those requests to routes, which can be layer 7, so HTTP layer 7 URIs that can do specific routing within that to different versions of application, or it can even go outside on the top and pass to an upstream. So that's where NGINX can actually do load balancing and actually can do outbound, NGINX Unit can do outbound proxying to even another service. So let's say you have a service where you have someone that you're working with and you want to build an app and you want to build it in Python, and maybe you want to have a component of it that's in PHP for some reason, and you also have a component that also needs to reach out to another network. You can actually have Unit make that outbound connection to that upstream as well. Then on top of that, you can serve static files, and then you can serve your applications using that as well. So for developers, what this means, again, is it's a simple JSON configuration. You can have one basic configuration for your application that it defines the place on disk where you're actually serving the application, what kind of users you want. You can even define how many threads of the application that you want to be created. So let's say you want to have 10 versions of your Python application. That could be one API call, and then later on you want to update that to 20 threads. One API call will instantly scale that application to 20 threads. So it's a really cool way to be dynamic and kind of have a dynamic tool for your application server. And it's the same, again, for all the applications because it's only one single API call. It also allows you to run the applications locally because it runs it inside of the actual Unit subsystem. So again, it's secure. So we don't have to actually create a new process. We don't have to make a call to another application or another service somewhere else. It's all handled internally in there as well. And then again, it gives you a high performance production grade HTTP interface that you don't really have to understand the depths of how HTTP is working. You can just be assured that the spec is doing exactly what it needs to from an HTTP perspective. And then for, if any of you are in a DevOps or a security operations role, I think we all know that as time goes on, you find yourself having to learn newer tools and be kind of more in that DevOps space. There's a lot of things that can help with that as well. Again, we can do the TLS configuration. So you can have NGINX Unit manage those TLS certificates. You can have it let you know, basically, if there's any kind of certificate that's going to be out of date. Could be a single API call to figure out if you need to update a certificate. And it really allows you to, again, the application isolation is a very important thing for security as well, where the application is running individually in those subsystems. So this is what the API looks like. Again, it is a very basic JSON object. It listens over HTTP. And you can see here we have a listener set up on all of the available IPs on that host machine, listening on 8081. And then we're passing all the traffic to an application called My Blog. And you can see here, probably not the best example, but I'm going to give some examples of Python later. But here we have a PHP application where we can say, hey, we always want to have two processes of this PHP app. but we also want to allow scaling up to 10. So if those processes start to run out of memory or start to take up too much utilization, you can actually scale them up automatically. You can have a particular location, a specific user that you want to serve the application, and an index file. And you can also do things like timeouts. And you can also define environment variables. So that's really cool because if you need to update an environment variable, you don't need to manage a file on disk. It can be just an API call, and instantly that environment variable is updated. The API supports get, put, post, and delete. So get is to obviously get the API. Put is to do an initial configuration. Post is to update that configuration, and then delete is to remove it. So you can actually completely wipe out the configuration with one single API command. You can also choose to do a Unix socket connection, which is more secure, so it's not available over HTTP. And you can also do, if you choose to, you could do it over HTTP over a specific IP import. So let's take a look at the examples that I have here. So this is a very basic Python code here that is basically just responding with a 200 OK, so HTTP 200 OK. It's also responding with a specific header and a value that's saying that the response is JSON. And then we're building a data object, and we're defining variables for each component of the data object. So we're saying, here's the message, hello from unit. This is the user agent. It's called NGINX Unit. And then we're also looping through all of the headers here for the request, and we're basically checking any of them have the match HTTP underscore, which is, as you guys have probably seen if you've developed in Python, that's what they look like. Those are the request headers. Then we're actually encoding that. We're also doing a SHA of the request as well, and then we're responding in a JSON object and then closing the connection. So it's a very simple response. This is like a very example hello world kind of application, right? Well, for unit, how would you deploy this? Well, you probably have already created a virtual environment of your application. You've gone in there, you've installed any requirements that you have into that particular folder, and then you've deactivated and taken away from the virtual environment. At that point, you have the application sitting on the disk. All you need to do is issue one API command. So in here, I'm doing it over a Unix socket. I'm starting unit, and I'm telling it that I want to listen on a particular Linux socket. And then I just show you what the log looks like here, because there is a log that you can see and get access to see what's going on. And you can see that when I started unit, I started it, and there was two modules available. One was Python 2.7, and one was Python 3.9. And that's because you can actually run multiple versions of Python in the binary as well. So you can have different versions of your application depending on what version you're running. And we also loaded OpenSSL, which is built into NGINX Unit. And then at that point, it started Python and it started up, but we didn't push the config yet. So here's what the config looks like. It's just a basic, again, JSON object listening on port 80. And we're doing a proxy to a Python app. There's the path where it is. There's the particular module that I want to use, which is WSGI. And then all I have to do is do a curl put command, pass that config file over JSON, and then connect over the Unix socket, and then instantly I get a reconfiguration done. And then here I did a curl, and we can see on localhost now my Python application is running through unit using Python. And then we can see that the JSON object that I built in the Python code is being displayed there. So if you guys want to get started, it's really easy. There's documentations on unit.nginx.org that go through the examples of how you would build with Python. Also, if you wanted to build with Go, any of those other languages I mentioned. If you want to look at the source code, it is available on, we use GitHub and we use Mercurial. All of the main contributions go through Mercurial, so that's going to be on hg.nginx.org, and you're welcome to do any kind of pull requests there as well. And then there's a mirror of it on our GitHub as well, NGINX Unit. That's my talk.